It's all crashing down on me. I'm sticking it home forever. I don't know if y'all noticed this about me, but I like to talk a lot and I like to see people, and this is really starting to wear on me a bit. So, anyway, pre synopsis washer method, it just looks like a washer. You have capital R, your big radius, little r is your little radius, your subtraction, your little radius from your big radius, and all we're finding is this area in here. And the reason why I didn't like his examples, they don't get very 3D. And I have some examples that I want to show you guys that show it more in a 3D representation that I think makes it look better. Some people like to refer to this as the donut method. So if you like donuts better than washers and you can picture a donut with a hole in the middle, not an apple fritter, not a long john, but a regular glazed donut, one of those maple ones. Oh yeah. Anyway, um, this sometimes this is called the donut method also. So I'm going to jump in and just show you a problem. The first problem we're going to look at, let me get it bigger on my screen. The one thing I will say I like about this better is I don't have anybody in the back of the room complain that they can't see anymore. So here we go. So we're going to have to determine the volume of a solid obtained by rotating a portion of the region. Now they have to tell you what it's bounded by. So we got y equals the cube root of x and y equals x to the fourth. So what you're going to, x over 4. So what you're going to see over here, here's your cube root of x, that's in the red. And then the x over 4, that's in the blue. So this green is the shaded region that we're going to be rotating. Now what you see right here, this is a 3D representation of it. If we're rotating it about the y-axis, the dark purpley part, I don't know if you call that purple, whatever it is, that's the hollow part. The pink part, that's the solid. So that's what you would see if you had a 3D representation of it. And what you have over here is what I told you guys a little while ago on Google Classroom. This right here, this link, that's what you're seeing off in the corner over here. So this right here is just a generic for this type of problem. So we're rotating it about the y-axis, and to find this volume, the only thing I do different than what they do in their formula is I go ahead and I put pi out front because I don't want to mess with pi. Now we're going to go from 0 to 8. If I didn't know for sure, well, let me back up for a minute on that. I would be going from 0 to 8 if I was rotating about the x, but I'm not rotating about the x, I'm rotating about the y. So I'm going to go from 0 to 2. Now, since we're rotating it about the y, we have to take both of these and we have to get those set equal to x. So I'm going to do the red one first. If I have y equals x to the 1/3 power, and I solve it for x, I get x equals y cubed. And for the blue one, if I have y equals x over 4, I'm going to have x equals 4y. So that's the first thing I have to do is I have to make sure I have everything in terms of y because I'm rotating about y. And I have to make sure my bounds go up and down. So if I did not know how to do this, I would have to take these two, y cubed equals 4y, take them all off to one side, factor out the y, and now we get y equals 0 and a plus or minus 2. So those are what I'm going to have here, and it's obvious it's in the first quadrant, so we're going to have to use that positive 2. There's where it tells me. So if I didn't have a picture and I just had to come up with my bounds the way I did, I know I would have to go from 0 to 2 because that's in the first quadrant. So now what we have to do now is we have to say, okay, capital R, we're rotating it about y. Capital R is the farthest out function. So I'm going to come in here. Capital R is my 4y, and I'm going to say 4y squared minus little r is to there. So capital R is going to have the shape in it. Little r is like the hollow shape that you have to do to get to it. So right here, I'm going to have, that was my y cubed, darn it, y cubed quantity squared. And this is what I would take This is what I would antiderive right here. Let me get these a little over out of the way. So this is what I would square it and work it out. Now I can keep working that out if you want me to.
Yes, please finish it.
Okay.
So
Thank you, just
on
Josh.
the whenever you, what are those other two graphs for?
What like this one and this one?
Yeah.
Okay, this is just a 3D representation of what you see. If you could take this green thing and twirl it around the
That's what it would
y-axis,
look
it
like.
would look like that. And this really is just, I'm showing you this. This is from this paper. Remember how I told you kind of like your one-stop shop? So the
Yeah.
problem I was just looking at was this guy down here. I'm going about the Y. I am away from the Y. So this is what I'm using. So these are just examples. I just kind of want to show you how to use this paper or this
Okay.
document, because this document just, it helped me out because there's all the different types of ways you can do it. So what you're going to see on these, you're always going to see one of these over in the corner, but this is just like a generic for this type of problem.
Uh, for the first one, how did you determine what was your capital R and what was your little r?
If I look at this, little r is always the smaller radius and capital R is always the larger radius. So if I look at it, capital R is going to be like on the outside of the shape, whatever rotating back. Notice you have to start from the axis of rotation. So little r starts from the axis of rotation, but it like takes in the hollow part of it. That's how we're subtracting off that hollow part. Because if we rotate this real fast around the y-axis, you're going to have like a odd cone shape, with like a curve to it inside it. That's what this little piece right here is showing you. If
Yeah, but
this,
I'm referring to like how are you able to tell y equals the cube root of x was actually the one that needs to be first and not the last one?
wow.
How are you able to tell that your 4y is the big R and
Because
your
4y
y?
is linear and y cube's curved. I mean, it's just, you have to recognize your two shapes.
All right.
Other questions for me? Good questions. No? Okay, just Josh wants me to keep going. So I'm going to do that. I'm going to have 16y squared minus y to the 6dy. That's what I'm going to have to antiderive. So I've got my pi up front. It's just along for the ride. And I'm going to have 16 over 3y cubed minus, that's a horrible 6, minus 1/7 y to the 7th. I'm going from 0 to 2. So check out the antiderivative. Make sure you're okay with it. And through the magic of the fact that I have the solution in front of me that I worked out earlier, my answer here, you would sub in the 2, sub in the 0, but you know that's not going to do anything for you. The only time you have to worry about subbing the 0 is if you have a constant out here at the end, and we don't. So I'm going to end up with 5/12 pi over 21. And that's my answer. The part in green shouldn't be too bad. What you really need to concentrate on right now is making sure you understand what capital R is and what little r is, and how it's always in your problem right here, it's always big R squared minus little r squared.
So, Mr. Shea, if you were rotating about the x-axis, would you try to get the y by itself?
Yeah, if you're taking the same problem, and we can do this problem if you want to rotate about the x-axis if you want to see it. Would you like to see that?
Yeah.
Okay, let me. I mean, I don't think it hurts to have another example of this stuff. Let me copy this, paste, and I'm gonna go ahead and get the picture again so I can draw on it. Why didn't I copy for me? Copy, paste. Okay, so what I'm going to do right now is I'm going to come over here. I'm going to cross this out, and I'm going to say about the x-axis. And when I do that, it's going to change. I'm going to get rid of this picture because that's it going about the y-axis, and ours is going to be different now. So let me cover that up. Okay, so what we're going to do now is we're going to rotate it this way. So we've got our pi out front. We know we're going from 0 to 8. And if we weren't sure, because we have the graph, it tells us. But again, if we weren't sure, we could just come up here and say, okay, the cube root of x equals x over 4, and you would just have to work that out. But they're not going to give you one like that because that would be harder to figure out by hand. So we're going from 0 to 8. Now, for this one, our r is our farthest out function. So we want it in terms of x. So we are going to say the cube root of x squared minus, and then our little r is that guy, minus x over 4 squared dx. And that's how you would set up the integral for that one. And I think I would bet you money on the test that that's all you're going to have to do on this problem, because they're having to combine so much stuff. That's the calculus. Setting it up. The any derivatives of these are usually pretty easy. I would bet, now they may prove me wrong, but I would bet they're just going to say set it up, but do not solve, because they do that a lot for these volume problems. Are you okay with that setup?
Yes, thank you.
Okay, so more questions on this piece right here? I'm glad to answer any you have.
It's always going to work out like where it's right minus left and top minus bottom.
What about that now?
Like, is that always how it's going to work out? Like, it's right minus left and then top minus bottom, just like the stuff that we've been doing.
Unless like say, I'm just going to sketch this over here. For example, let's say our shape was down here like this. And then if that were the case, my r would be that. My little r would be that. So I hate to say like top minus bottom or right minus left. What I do on all of these is I just draw the r's, because that one's technically bottom minus top because it's in the fourth quadrant. But if you want to think about it as being the top of the shape minus the bottom of the shape, if that's how you see it, that's fine. Because it's always going to be bigger r minus little r, wherever they're at. Does that make sense, Maddie?
Yeah, thank you.
You're welcome. Other questions for me? And this is just your first example. I'm going to do a couple more. So if there's no more questions on this one, I'm going to go on and take a look at another one. Okay, my next one I'm going to look at, let me click it over here, is this guy right here. Now, what I need you to notice is different. We are still having it bounded. We still have x squared minus 2x is the parabola, y equals x is the red line. So this green is still what we're rotating, but if you'll notice, we're not rotating it about the x-axis. We're rotating it about another line. So if you look up in the problem, determine the volume of the solid, we have our two functions, and they have to tell you what you're rotating it about. If they don't tell you what you're rotating it about, you don't know what to do. So what I have right here is, again, off that what I refer to as a cheat sheet. What I look for when I'm looking at this page right here, where the rotation is, because it could be down here, and there's another scenario for it being down here, but we're above, our function is underneath. So right away, before I do anything, I'll come over here to my picture and I'll say, okay, I know r is that, and I know little r is that. We're rotating about a y equals 4. Well, that's just like an x line, like an x-axis line. So my volume for this one, we're going to be going from 0 to 3. Oh, I forgot my pi. What's my pi out there? And it's going to be r squared minus little r squared dx. So now we got to figure out what r, big R and little r are. So let's talk about big R. If we're talking about big R is this guy right here. And if you'll notice, it says big R is C. Oh, wait a minute, I might pick the wrong one. Hold on. Let me jump back over here. Lost my guy. I picked the wrong one. Let me take a picture of this one, cover that one up. Did it not show up over there? Maybe it's still thinking. Okay. So what I'm looking at here to get R, I'm going to have to say, okay, my C is 4. And I'm going to say 4 minus that parabola. Because I've got 4 minus that. And that's how I'm going to get that outer radius. It's C minus whatever the bottom function is. My bottom function is x squared minus 2x, just like this g of x down here. So take a minute and look at that. That is this piece right there.
Did you post that little cheat sheet thing
Yes.
on the Google Classroom?
It's on Google Classroom, yeah. And I would look back at that a lot because once you understand it, it makes it a lot easier to use it. Now let me do R over here. So we're looking at big R. This is our big R. This is our big R over here. They're the same, that's the same type. Now, if I want to look for little r is the hollow part of it. They got little r over here. So for little r, it's going to be, in our case, 4, which is always whatever c is, minus our function, our red function, which is just x. So now I have little r, and now I have big R. So I'm going to go ahead with big R, just because I'm a little bit anal, and make it negative x squared plus 2x plus 4. Okay, I just got rid of the parentheses and put it in standard form. And I'm going to come over here to my equation, and I'm going from 0 to 3 of negative x squared plus 2x plus 4. Notice I'm putting in parentheses. The first set of parentheses don't matter. I just do it. Well, I guess it does matter. I have to square it. Minus the second set of parentheses squared dx. And this would be what you would have to antiderive. So do you see why I tell you a lot of times they're going to say just set it up, don't solve it? Because you see all the horribleness of algebraic problems you could do in that, because you would have to multiply this by itself twice. You have to FOIL that. And like I said, most of the time they'll just say set it up but do not solve. So ask me questions on that black line or any of it.
If they didn't give you the bounds, would you still set equal just the original equation, or would you have to include the c in it?
No, you would just say original. You would say x squared minus 2x. That's a really good question. I never thought about it.
So, if the axis of rotation was instead like x equals 3, would that change our equation to being 0 to 3?
Are you talking about right here?
Yeah.
All that does, that has nothing to do with your bounds. All that has to do is what big R and little r are. What I'm doing in here in green right now is this is how I would find my bounds. So I get x equals 0, and now I get x equals 3. So this part doesn't have anything to do with this part. So find your bounds like how you always would. The only thing what you're going about, the only change that does to you is it changes how big your R is and how big your little r is. That's why I like this little cheat sheet here, because It had everything on it that I needed.
If the line of rotation was like below the shape, like
Mhm.
say it was down at -2 or
Mhm.
something, would you do like 2 plus the
That's a really good question.
equation?
Let me show you. What you
Okay.
would have over here, if it would be underneath it, like we just used this one, if it would be underneath it, you would just say your capital R would be your f of x plus whatever c is. So not when I'm saying c, let's say that's a -2. Right here, I would be putting +2.
Okay.
Okay, and I would have my g, whatever my g function is, +2.
So you would do plus like the absolute value of the thing?
Basically, yeah, because your
Okay.
radius is longer than it would have been. Because if I would have just gone from f of x down here, it's like I'm shifting my x-axis down too. So I have to, my r is bigger than it would have been if I was just rotating it about the axis.
Okay. That makes
Okay.
sense.
And this whole sheet has it on it. Go ahead.
So whenever you plug in the C, you don't worry about like the positive or negative of it?
Correct. Exactly right. Because if you'll notice, let me zoom in on this guy. If you'll notice, it says -c right here, but in the equation itself, it's just c. Because what we're doing, we are taking our x-axis like we normally have it, and we're moving the whole thing down to c. So like regular, if I was just doing this about the x-axis, my capital R would be from here to here, and I would stop if I was rotating about the x-axis. But because we're rotating about something else, we have to account for that extra space. And that's why you're seeing the plus C. So even though it's like there's a -2 right here, I would have a +2 right here and a +2 right there.
All right, thank you.
You're welcome. I like these questions. Ask me more questions. I don't feel like I'm quite so alone. No more questions? Okay, I got one more to show you then. Okay, we did one about the X, a line on the X, how do I say this? A horizontal line. Now we're going to do a vertical line. So we're going to take a look at this one. And a hint for these, we only really have two ways to do circles. We either do discs or we do washers. So back in the good old days of yesterday, I kept talking about it's flat against the axis. It's flat against the axis. If it's flat against the axis, it's just a good old fashioned. This one would be from 0. If I was going about the x-axis, 0 to 2. If I was doing it this way, 0 to 2 y squared dx. There's my y. So it's flat against it. The ones we're talking about today aren't flat. This one's not flat. This one's not flat. And the last one we're going to look at right here, it's not flat. Okay, so that's how you tell if you're going to use the washer method or if you're going to use the disc method. So this is our shape. We have y equals 2 square root of x minus 1, which is the blue purpley one. And then we have y equals x minus 1, which is your red one. And we want to rotate it about x equals -1. This is what the lighter pink color, or purple, whatever you want to call that, magenta, that would be the shape that we would see getting spun around. It had a really big hollow part on the inside. So if we're going about a y-axis, we need to have everything in terms of x equals, right? That's just what you have to do. So if I'm looking at this, and I'll use this in a minute. Let's come over here. I said the first thing I like to do is get my R. So my capital R is to there. My little r is to there. Are you all okay with me drawing those two? Do you understand why big R is where big R is and where little r is where little r is? Any questions on that? Okay. If there's no questions on that, we know we're going to have this in terms of dy. So I have to take these equations and make them x equal. So I'm going to end up with y over 2 equals the square root of x minus 1. I'm going to have to square both sides. And this equation is going to end up being x equals y squared over 4 plus 1. So that's this guy right here. And the other one's super easy. It's like they give you one that's a little bit harder and they give you the other one that's super easy. So those are my two equations in terms of x equals. So we have to think about now, I want my volume. I've got my pi out front. I'm going from 0 to 4. If I didn't know that, I would take these two, set them equal to each other, and solve it and find those two answers. So now if you look over here, this is like off the cheat sheet. Our capital R is the F1. So our capital R, if I come over here, is going to be our y plus 1. That's our function. Okay. Plus what? Plus 1. So if I'm looking at my cheat sheet over here, this is like my f sub y plus my c. And then I'm going to say minus. Now we've got to do little r. If we're going to do little r, we are going to be going from here to here. So we're going to say y squared over 4 plus 1. And again, we're going to add plus 1 to it, squared dy. And looking at my cheat sheet, this is like my gy plus my c. I'm pausing now for meaningful thought and any questions.
On the AP test, would you like put those together, make it like plus
No,
2?
I wouldn't. If all they're wanting to do is to set it up, honest to God, if all I had to do was set this bad boy up, I would leave it like that and not touch it, because knowing me, y'all know how I add, I would put y plus 3 squared. Or I would say y plus 2 cubed. Or so I would jack that up somehow. And I don't want to take that chance. That is a perfectly good answer. Now, if it's just not in you, you just can't handle it, it doesn't hurt at all to say y plus 2 squared minus y squared over 4 plus 7 squared dy. Okay, that's perfectly fine. You get it wrong, but that's perfectly fine. And here's the deal. Do you see right above it, I have it right? They would grade that blue line that's wrong, even though right above it you have it right. So you really want to make sure, if you're going to simplify it, you make sure that you do it the right way. Another thing I would say is, I'm trying to think what else I want to talk about with it. Not really anything to say about it. I mean, that's what I would do, and I would leave it at that.
So even though it says it's about the line of x equals -1, it's still plus 1 when we're saying it's plus c.
Yeah, because if you're looking at basically what you're doing, if we...
Oh, wait, is that because the actual equation is minus c, but since it's negative, it turns into positive?
I'm not sure. What I'm thinking is normally if I rotate about the y, my little r would just be, my c would be 0. But we're moving our rotation line, so we have to count. I always go back to, okay, what's it do here? And then how do I get to my new line? If I was right to here, my c would be 0, but I'm adding 1 to my little radius. I'm adding 1 to my larger radius, and that's where this plus 1 and plus 1 come into. My radius is much longer. If I came in here and just broke it right here, and if I came in here and if I was rotating about the y-axis, that would be my r, and that would be my big R and my little r. But because I have moved my axis of rotation back, I've got to add 1. That's where that 1 comes in. And I've got to add 1 to this one to get to my axis of rotation, and that's where that 1 comes in. Okay, more questions for me? I had more questions today. Anything? Okay, this is it. This is all of 812. So,
I've got a homework question.
well, okay, yeah, we'll do that in a minute. Let me pontificate a little bit more. Here's what I'm going to do for tomorrow. For tomorrow, if you have no questions, don't come to class. All tomorrow is going to be our homework questions over 8, 9 to 8, 12. I would appreciate it if you would text me or message me the ones that you do have questions on. That way I can be ready to have them up here and ready to work through them. But tomorrow is Friday Eve, right? I mean, it could be Monday. I have no idea what day it is. But anyway, your test is on Friday. Now, when I say your test is on Friday, you have all weekend. Okay, I'm going to open up the test on Friday, and I'm going to close the test on Monday when class starts. So it's not like I'm done with being so worried about this. This is a test this is a test to pad your grade. Okay, so make sure you take it. Make sure you're telling the people that aren't here about it. I'm starting to call home. I'm surprised I have to call home on AP, but I'm going to have to start calling home on some people that aren't showing up and aren't turning stuff in. So make sure you're getting some stuff turned in. A couple of y'all still haven't taken that quiz from the other day. If you haven't, you need to email me.
Hey, Mr. Shea.
Yeah.
Isn't next week technically spring break though?
Oh, that's right. Yeah. So you just have to have it done by Monday. And we're not having, screw that. We're not having class. Oh, did I say that out loud? We're not having class next week. Blah. But I just want to get that test done so I can get the grades in the grade book. Yeah. So we're not doing anything next week. I may throw some stuff out in Google Classroom. If you're bored out of your mind and you want to start looking at review, and you like calculus, I might throw some review stuff out there. When we come back, our class is going to look a little bit different. I'm not going to be teaching it. Two of the best calculus teachers in the world are going to be teaching it. Her name is Verge Cornelius, and then we have it's either Brian Passwater or Tony Reeder. Tony Reeder is the one where these notes come from. They are like the AP calculus gurus. Like, I want their autograph. Like, I have a T-shirt with their faces on if I could. They're going to be teaching the review classes. I'm going to be watching them along with you. I'm super excited about those, but we'll talk about that after we come back. So I'm done
As long as
talking.
they're not,
What?
as long as they're not like Michael.
What do you mean? As long as they're not like.
The advanced Kentucky guy.
Oh, I hope not.
Michael.
And I'm going to be watching them with you. We'll like have watch parties. And if it's like totally horrible, we won't keep doing it. But I just feel like AP is putting out review sessions for the AP test that the AP is writing, that the AP is giving, and the AP is grading. So I feel like would be stupid for me to try to do what they're doing, and I want to learn from them too. So if it's horrible, we'll revisit it. But I don't think it will be. I'm pretty excited about it. I'm kind of geeked out my little geeky calculus math mind. So I'm done with new material. I will be glad to stay on here and answer some questions if you have any. So, any questions?
Homework question?
Yeah, whatever.
Can you do number 3 on 8788?
Number 3. All of it?
But you can just do like one, like part A or part B, just like something.
Okay, so do you see it on the screen?
Yes.
Okay, let me get my calculator up. Always takes a minute. Okay, so we have to find the volume of a solid whose base. So we have a parabola and we have a line. So let me get the calculator, because the first thing I'm going to do, if it's calculator active, I'm tossing in my calculator. It on the AP test, just FYI, they're saying that if you try to use a calculator, it's going to make it take more time. It's designed to not be calculator friendly. So I'm sure you can have your calculator sitting beside you. You can rub on it if it makes you feel better, but I don't really think it's really probably not going to help you a whole lot on this test. But we really haven't used a whole lot in class anyway, so that really wasn't a concern of mine. Okay, so I got x squared minus x minus 3. And then I've got y equals x, and I'm just going to hit zoom 6. Okay, so we have this shape. So the first thing I want to do when I have this shape is I want to go ahead and find my 2 intersection points right here and here. So second calculate. I'm going to hit my intersect. First curve, second curve. Let's arrow down because I want to get this first one first. So I have a -1. So I'm going to come over here and write down real quick. I know I'm going to be having -1. And then I'm going to hit second, calculate, intersect again, enter. But this time I want to arrow it up to get closer to the other one so it knows which one I want. And that one's going to be 3. So I'm going to come up here and I'm going to have a 3. Okay? So if I have something like, I'm going to attempt to draw it. If I have something like, we're over here at 3, 3, 3, and this one was, that's not the most horrible ever. Okay, there's my shape. So I am going to be having my top minus my bottom. So I have the top for this one is x. The bottom is the x squared minus x minus 3. And this is just a generic sitting up here, okay, because I just notice I'm not putting it in one of my blocks yet. So it's just kind of information I have. So if I want squares, I'm going to be going from -1 to 3. My squares are going to be it's all perpendicular to the x-axis. So my squares are going to be going from here to here. So that's the side of one of my squares. So it's going to be top minus the bottom. Notice how I write this. I'm distributing that minus sign squared dx. And that's what I would have to take the derivative of. Now, I'd be daggone if I'm going to do that and not come over here and hit alpha window, f an integral. Oh, crap. I hate it when I do that. Let me get out here. Alpha window, number 4, from -1 to 3. And I'm just going to type it in. I mean, you can type it in just like you see it. So just type it in just like we see it. And there's your answer. I would go 3 past the decimal, 34.133. And you don't have to show any more work than that. Is that good, Ben?
Yeah, so for like the semicircle,
Mm-hmm.
you would have 1/2 pi in front and then
Yes.
radius squared, so like the side squared.
Perfect. Yeah. You have that up front from -1 to 3. And no, be careful. No. Because what you see in here, this top minus bottom, that's your diameter for a semicircle, right? So I would have to take the x minus x squared. I got to rewrite that. I got too much math teacher in me. I leave it like that. -x squared plus 2x plus 3. Divide that in 2 squared.
X squared's positive.
Yeah, I know. No, it's not.
Yeah, it is.
No, it ain't.
Then what's that from?
This is my top minus my bottom. My top is my x.
Okay. I was looking at the original.
Usually I'm wrong. I'm so excited to be right. Okay, then what I would do, you know how I don't like fractions? I would go ahead and put a 1/4 out here. Because just 2 squared, and it's in the denominator, is 4. And then you got exactly what you had up there.
So where'd you get that 2 from the bottom?
Because isn't top minus bottom your diameter? My diameter. Yeah. So I've got to take half of that to get my radius.
Okay.
Okay.
Yep. Thank you.
You're welcome. Any other ones?
Could you help set up for Eve, like on number 1?
Okay, let me erase this stuff. Clear ink, number 1, E. Okay, so let me take a look at it first here. Okay, so we want to find the volume of a solid. So we have, if I'm looking right here, we basically have that and over 2, 1, 2. So it should be more like that. Okay, so we have that, and we want to find the volume of a solid whose base is in the region bounded by the parabola and the x-axis from 0 to 2. So we are looking, if we stop it at 2, we're looking at this area in here. So for E, we have an isosceles right triangle whose base is the hypotenuse. So basically what we have is we have triangles in here with the point coming out at you. Now I'm going to write it up here because that down there's too low. If I have a right triangle and it's isosceles, those two match, right? And there's my right triangle. So I know my hypotenuse is just going to be x squared because my hypotenuse is top minus bottom, x squared minus 0. Now, if I'm looking at this and doing like Pythagorean theorem, I'm going to call both of these sides a, like a squared plus b squared equals c squared, but they're both the same. So I'm going to say a squared plus a squared equals h squared. So 2a squared equals x to the fourth. You okay with that?
Mm-hmm.
Divide both sides by 2. And then a is going to be the square root of x to the fourth over 2. So we know to find the area of a triangle. This isn't equilateral. We can't use that fancy radical 3 over 4 side square. We have to use the good old-fashioned 1/2 base times height. But now we have our base and our height. Our base and our height are these two guys. So if we have 1/2 base times height, for our case, it's just 1/2 a times a. So I'm going to go from 0 to 2. I'm going to put the 1/2 out front from this 1/2, and I'm going to say the square root of x to the fourth over 2 quantity squared dx. And I'm going to end up with, just to try to write it a little bit neater, I'm going to have x to the fourth over 2, getting rid of the square and the square root cancel each other out, dx. And that's how I would any derive.
Okay, thank you.
You're welcome. Anything else, guys?
Mr. Sherry, on the 8.9 stuff, do we just do either the disk or the washer method?
I think what they want you to see on that, let me jump over that, and I haven't forgotten you, Shane. I've got some stuff I need to send you. Let me clear this out. Jump over here to it real quick. Shoot. I think what they want you to do is they want you to graph it, and then if you realize it's flat against the x-axis, little r equals 0. You know what I'm saying? Like if I did this one, if I graphed this one, I would have y, so up here 1, 2, 3, 4, down 1 over 1, down 1 over, down 1 over. So I would just basically have, and let's take a minute to appreciate how good that line really pretty much looks. So I have that x equals 0, y equals 0. We are going to be rotated about the, so if we're going to be rotating it about the x-axis, for my disks method, my r, I'm just going to go from here up. My r is going to be just the 4 minus x. For the washer method, it's still 4 minus x, big R, but little r, there's not one because it's solid against that surface. I think that's what he's looking for there. For you to recognize what big R and little r are in both situations, how the disk method and the washer method are related to each other.
So you said like on the AP test they wouldn't expect you to like most likely solve all this out.
Correct. Typically, and I really believe especially this year, they might want you to do like the area, solve it for the area, but usually for the volume, and we'll be looking at some of the FRQs. For the volume, typically it's set up but do not solve.
So would it be okay if we just like do the calculus, get to the interval, and then like plug it into our calculator to get the answer?
Yes, totally. I'm fine with that. I'm down with that. Everything's out the window. Use your calculator. I will say though, again, like I said earlier, on the test, they're saying that they are making the test where it will be faster to not use your calculator. Like if you depend on your calculator, I don't really think any of you guys do really in calculus because we haven't used the calculator that much. And
Yeah, I would
anything.
rather save time on this one. Basically, is really the only reason I ask.
Yeah, I would totally do that. That's fine.
Okay, thank you.
You're welcome. Anything else? Who else is still with me? Wow. All y'all are still with me. That makes me feel so loved. Anybody else have a question? Okay, you know where I am. Just a click away or a text away. If you need me, please do so. Um, again, this is due tonight, so I'm expecting some more questions tonight. In fact, let's go ahead and say at 6 o'clock tonight, I will be on Discord in study room 1, or I'll just be on Discord on the classroom. If you have questions, come there. I'll record whatever we do for in the study session at 6, and that way we can kind of all be together. Anybody that has questions, okay? I'm gonna jump off here now. I'm gonna have to teach pre-calc in about 9 minutes. Bye. Hey, Michael, say goodbye to me.
Goodbye.
Bye.
Bye bye.
See you in an hour.
Okay.